I'm Matt Swartley with Chariot Solutions, and I would like to introduce you to Josh Long, who is a Spring developer advocate at VMware. He keeps extremely busy promoting and educating others on Spring and related technologies as an author of 6 books and numerous best-selling training videos, an open source contributor, a podcaster, and a YouTuber. Josh is going to speak with us today about the big year ahead for the Spring framework. So please welcome Josh Long.
Okay, good stuff. Thank you for that awesome hand up. I appreciate that. Hi, everybody. Let me share my screen. I think that's important. Let's see here. We've got about an hour, I guess. So that's not very long. We have to go fast. Let's get to it. So my name is Josh Long. It is so good to be here with you all today. I work on the Spring team, as was just well explained. I'm a Spring developer advocate, a Kotlin Google developer expert, a Java champion, and most of all, I'm at your service. So should you have questions, comments, feedback, whatever, don't hesitate to reach out to me via any of these coordinates. And there's my blog. I've got a new book where I'm updating the book. Actually, it's 1.1 release. I do a YouTube series every Wednesday, although it's been a weird month this last month. Jury duty, vacation, and a bunch of other things mean that I haven't had anything for the last few weeks, but stay tuned. Podcast every Thursday, Twitch every now and then, Twitter, LinkedIn, email, blah, blah, blah. Okay, and most importantly, I'm super excited about this year, right? This is 2022, and we're at a kind of an interesting point in the journey right now. We're as we talk, it's April 2022, and the goal at the end of the year is to have Spring Framework 6 come out, right? That's the brand new version of Spring, the next generation of Spring, on top of which we will base Spring Boot 3.0. Now, these new generational releases give us some big opportunities, right? There are some huge opportunities. Unfortunately, not all of that is yet ready to show. But a lot of the themes that we can talk about, a lot of the things that will be in there, we can talk about in terms of what's here today and how that'll be improved and what that'll look like going forward. So we'll do that today. Now, there's a couple of things we need to understand about these new releases. First of all, they bring with them some new baselines, right? So those new baselines include Java 17. So if we go to my second favorite place on the internet, obviously my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, then you can begin a journey here at start.spring.io. And we're going to build a new service. And that new service is going to use Java 17. Now, this will be the baseline going forward, right? And it makes a lot of sense, right? Java 17 may seem a little aggressive in middle of 2022, but by the time Spring Framework 6 releases by the end of the year, before the end of the year, it'll be already, we'll already have Java 19, right? So it's already going to be two releases behind, and it'll be it'll already be one half of the way through the long-term support period of Java 17, right? They changed the update cycle so that you get new releases every 6 months. And now, instead of waiting every 3 years for a long-term supported version, you get a new release every 2 years. So we can expect, I guess, Java 21. I guess that's right. Yeah. Java 21 will be the next long-term supported release. So we're not, Java 17 seems aggressive now, although it is already Java 18. But consider the lifespan of a typical generation of Spring Framework. Spring Framework has moved more and more to catering to other frameworks because it is a thing that is brought in by the likes of Spring Boot and Spring Cloud. And so it doesn't need to change all that much for user-facing stuff. I mean, there's a lot of stuff that's in there, and a lot of stuff that will be dropped or changed in Spring Framework 6, because again, we don't change this very often because it's a generational thing, right? The last time we released a new version of Spring Framework was Spring Framework 5 in 2017 in September, and that version had a Java 8 baseline. Well, that's a long time ago, right? I mean, Java 8 is an ancient, creakingly old, long since past its prime version of Java that has no business being on anybody's applications or servers. Java 8 was in 2017, so that's nearly 5 years ago. September 2017 is nearly 5 years ago. By the time Spring Framework 6 releases, it'll have been more than 5 years, right? And so if you extrapolate out a little bit, if you look at the sort of horizon, you can see that, 5 years from now, my goodness, what will the world look like? It'll be 2027, and we'll have, what is that? 2 releases a year, so that's 10 more releases at least, and we're already going to be 2 releases in, so call that 12 releases from Java 17. What is that? Java 29. My goodness, the world's going to be very, very different by the time it's time to think about Spring Framework 7, or whatever that looks like. If we extrapolate that and assume it's going to take 5 years, which there's no reason to assume that, but just kind of extrapolating out. I mean, Spring Framework 4 came out in 2014, and then Spring Framework 5. I'm sorry, 4 was in 13 or 14. And then 5 was in 2017, so that's 4 years ish. This time it'll be closer to 5 years, right? These releases come fewer and further between, because a lot of the work that people consume directly these days is in terms of the auto configurations in Spring Boot. And since you don't really often interact with those auto configurations, it's you interact with the benefits they provide. There's no API per se to which you couple yourself. So I think it's a very conservative baseline, right? That's obvious, and we'll see as we use Java 17 in today's demo. You'll see why Java 17 is such a nice fit in some cases. I mean, there's just so many wonderful things about Java 17. Obviously, the syntax itself is amazing. There's multi-line strings. There's the var keyword. There are switch expressions. There's just all sorts of stuff, right? All sorts of stuff that just makes records. My goodness, records are amazing. There's just so much good stuff. So it's syntactically a better choice. It is syntactically a more rich, more concise, more beautiful Java. It's also technically superior to Java 8 in every conceivable way. It's faster, more operations friendly, more secure, more robust, more capable than anything that Java has in every way. And it's also morally superior to Java 8 in every way. You're not going to like the look of despair and frustration in your children's eyes when they see that you're still running Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. Java 17 is the right thing to do in 2022. And bear in mind, judging just purely by the number of versions alone, Java 17 is more than twice as good than Java 8. Okay, so there's a lot of reasons to be using Java 17 and to move away from Java 8. I hope I've made some of those here. I like Java 17. There's some really cool stuff in Java 18 that just came out. Like there's actually a pluggable SPI for network resolution. So basically the DNS resolver bit inside of the JRE and inside of the JDK, that thing is now pluggable. So by default, it just delegates to your operating system DNS. But I mean, imagine the possibilities. You could write one that actually overrides the resolver and resolves to a service registry or something like that. I mean, there's just some really interesting stuff happening in all the new versions of Java. So Java 17 will be the baseline for Spring Framework 6. And we'll also have and this is where it gets a little sad, let me try that again. Very, very happily, we'll have a new version of Jakarta EE. Sadly, however, the packages will have changed, right? And so there's a little bit of work, not a lot. It really is. It's the simplest, biggest find and replace you probably have ever done, right? There's no other refactorings. I think it's Jakarta EE 9. So basically what happened was years ago, for reasons that have nothing to do with technology, the combination of projects that formerly known as Java EE got moved to a separate foundation and to the Eclipse Foundation, basically. And there they were open sourced, right? They were moved out of the old process and moved to a more open source model. The only problem is that in order for this to work, in order for them to do this free and clear with all the rights and all that stuff, they had to agree to rename the packages. And so as a result, every bit of code that's ever been written since it was called J2EE 20 plus odd years ago to Java EE and now to Jakarta EE, all that code breaks. But again, it's not a hard break. It's just a package. You can just replace it, right? I would be surprised if the IDEs don't offer that was easy button. You just click and replace, and it'll automatically replace javax.asterisk with jakarta.asterisk. And to their immense credit, the folks over on working on Jakarta EE have done a pretty good job of making sure that there was an easy migration path, right? So if you had Java EE code from, what was it, 7, I guess, and then you upgrade it to 8, there's some new features, but then 8 to 9, there's basically no new features. All they did was re-release the same thing, but from the Eclipse Foundation. And then from 8 to 9, wait, was it whatever the most recent one was, they moved that over to the new package. So it's the same code, no real major new features, certainly nothing that breaks backwards compatibility. But the only thing that you have to worry about is that they renamed the package. So you had one release that served only to establish that it's the same old thing as before, but now under the new license and the new foundation, and then another release to change the package under the new license. So basically, there's been 2 versions where they haven't really added anything, but again, it's just to promote a very smooth migration path. So that shouldn't be that big a deal, but it is a thing on which a lot of projects that people use depend on, right? So if you're doing JPA because you make terrible life decisions, you'll be affected by this, right? If using bean validation, you'll be affected by this, right? So these are all these common projects. Now, that said, I use neither, and I haven't for years, and it's entirely possible to go your entire day without hitting a JavaX dependency these days, but I concede that's not the majority, certainly not the the tradition of people using Spring. So keep that in mind. So Java 17 and the latest and greatest Jakarta packaged namespaces will be the assumed norm in the new release. So we're going to use Spring Framework. We're going to build a simple service here. I'm going to use Java 17. And again, I just want to run through and show you a bunch of features and kind of look at where these things, where they will go in Spring Framework 6, right? I can't really show you all the stuff in terms of Spring Framework 6 yet because it isn't, it's not usable. All the stuff I want to show you doesn't work yet. So not, some of it does, but not enough for this to be compelling. So we'll talk about some of the things that you can expect to see in terms of today's generation. And that's good because some of the stuff you can already use today. It's just a little different. It'll be useful to understand how that works today. So we're going to build a new service here at start.spring.io. We're going to add a Spring native support. We'll talk about that in just a second. We're going to add the reactive web support. Sure. We're going to add the Actuator support. We're going to add R2DBC support. And there you go. There's our simple application. We're going to hit generate and open this up in our IDE. So here we are. Good stuff. Oh, JPA buddy. Oh, why is that even installed? Okay, cancel. It's like they knew we were talking about them, and it reared its head after years of dormancy. Okay, so here's our new application. It's just a regular stock standard Spring application, public static. Yo. Okay, I don't care about this. Go away. Customer application. Okay, good. So there's our public static void main application. It's just an application that talks to a database. Some of the stuff you'll have no doubt seen before, right? We've got the Spring Boot support for reactive data access using RGBC. I've forgotten to bring in an embedded database, so let's just do that here. Control space. I'm going to hit copy and I'll paste this into the buffer here. So voila, re-import. Okay. So we're not going to spend too long on this. I'll just build a simple application that talks to the database. So we have something with which to play, right? Something with which to work. So at ID, there's this interface, customer, repository, extends, reactive, CRUD repository. Now, reactive programming is one of those things where if you aren't using it, then now's a good time to start because it is awesome. It's a way to describe your data in terms of asynchronous computation, basically, and that gives the runtime an opportunity to always do the work that you're doing only when you need to do it on the CPU, right? So if you want to do reads, you can do so using asynchronous IO. Those reads, you can ask for the bytes, but then you free up the thread and you give those threads back to the runtime. The runtime can then put those threads to use for something else while it's waiting for those bytes to arrive. As soon as they arrive, you get an interrupt, and that interrupt is the callback, kind of, and then you are allowed to continue your processing. So the runtime makes sure to let you, to put you on the CPU whenever it's possible to use the CPU for something, whenever you need to, and then it takes it off and backgrounds it. So while you're waiting for something, and this has the effect of letting you repurpose threads to a much greater extent. Obviously, one of the big things we're all hoping for soon will be Project Loom, right? And Project Loom will largely moot a lot of the cost of repurposing threads. So there, reactive programming will have one fewer application, one fewer use case, or at least one half of a use case less, right? There's still a few other use cases for which reactive programming, I think, is just really compelling, and it's why I always use it for all of my applications today. The other use case is ease of composition, because you have one abstraction with which to describe all the data in your system, in your application, the data coming from your message queue, from your REST API, from WebSockets, from whatever. It's all just a publisher. And because of that, it's very easy, no matter what the size, the cadence, the longevity of that stream of data, it's very easy to compose these different streams, right? To put them together in a way that you can operate on them, you can compose them, you can filter them and stream them and so on. And this becomes very natural, as we'll see in a little bit here. So I like reactive programming because it gives you ease of composition, and also because it's a single abstraction at the core of your API, you have a natural place in which to add support for robustness. And there's a few ways you might do that in your applications. One is you might introduce support for back pressure, right? Reactive programming supports this concept of back pressure, which is basically when you have two sides of a producer and a consumer on the same connection, and one side is going faster than the other. Back pressure allows the consumer that might be overrun by the overly fast producer. It gives it a way to say, no, hold on, I can't handle any more data. Please slow down, right? And that way you can avert the possibility that your services will get overwhelmed and crash. So back pressure, ease of composition, and resource efficiency in terms of thread reuse. Not to mention, it's just a nice, consistent API, right? And because it's consistent, you just have less to learn, right? There's so many things that exist in the Spring ecosystem that were introduced as by the need to make more robust these various interactions that we do when building distributed systems. All of those just go away. So yeah, you can use Spring Cloud support for Hystrix or resilience for J, but it's just built into, there's circuit breaker and things like that built into Reactor. Same thing for rate limiting, right? If you want to do that, there's you can do all sorts of things easily without actually having to bring in an extra library, right? Circuit breakers, retries, all that kind of stuff. If you're using imperative blocking IO, then yeah, you should definitely be using Spring Retry. You should definitely be using Spring Cloud Hystrix and whatever. But if not, just you can throw away so many of those different SPIs. Okay, so here's our interface, our type. And by the way, that's a record. Isn't that nice? What that gives me is a field. It gives me an accessor for this field called ID and an accessor for this field called name. Obviously, it's not a Java bean, right? If you've probably seen this. So customer, new customer, one, whatever. If I go here, customer, it says ID and name, which is fine. Spring knows about what to do with that for every project where it makes sense to support that, except obviously Spring Data JPA, right? So JPA, we don't provide the ORM engine, right? JPA, we're using Hibernate underneath the hood, or we're using a JPA implementation, since that's what JPA provides, is an ORM. And there, JPA doesn't know about what to do with records, so you can't use those for JPA just yet. But someday soon, I expect things will pick up more steam, and they'll start adding these sort of low-hanging fruit, obvious features. In the meantime, every other Spring Data module, of which there's like more than half a dozen that I can think of right off the bat that support this, of that, those should all support records as they become more updated. Okay, so here's our application. We want to have a controller. So I'm going to build a simple HTTP controller, one of many types of controllers, right? And there's a, as we'll see, there's a lot of different types of controllers here in the Spring ecosystem. So we're going to use the customer repository. Okay, turn that into this at git mapping customers publisher. Whoa, customer get. Turn this dot customer to find all. Good, that's a reactive type, that flux, that's a reactive stream type. And then finally, we need some sample data so that we have something to look at, obviously. So we're going to create a new file here called schema.sql. Create table, customer ID, serial, primary key. name varchar 255 null. Good, and some sample data. Yeah, so we're going to just insert some names of people who are in the Spring team. Hi, I'm on the Spring team, at least so far. I don't know why. They're too awesome. Madura, and this is like, in any list, I should always be at the bottom. That's fair. I'll be the first to volunteer that. Violetta, Olga, Stefan. Okay, and Spencer. So there we are. There's 8 names. So now if we run this application, and we're going to create a little bean here just to confirm everything's worked. So runner, actually we got the rest endpoint, don't we? So we can just run this. Let's go ahead and start it. Okay, so localhost customers. There we are. There's our data. It's worked great. Are we ready to go to production? Not quite. This is where we can look at our first thing here, which is the actuator. So Spring Boot has a module called the actuator. You have no doubt seen this. We're going to enable some, let me see. We're going to enable all the endpoints. We want to show all the health details here. Health, show details always. And we want the Kubernetes probes. Why not? Restart that. Okay. So here's our application. Go to the /actuator. You've got a number of managed HTTP endpoints, and this gives you information about the application itself. We're not going to go into all this too much, except to say that if you're doing Kubernetes, there's an endpoint here called health, and we also have probes for liveness and for readiness, right? That's there. And we also have this metrics endpoint, and the metrics endpoint is where I think things get really interesting. And the metrics endpoint right now is just accumulating things in memory. And so you can ask for statistics, just random statistics that the JVM keeps for you, but also request statistics that you can capture that might pertain to your OKRs, your whatever you feel like you need to be measuring to understand whether your service is successful or not. How many new fulfillments, how many new customer signups, how many checkouts were completed successfully, how long did it take, what's the average time, the mean, the median, the 99th percentile, etc. So all these different statistics are useful if you're just running them, even if you're just running one node and you're keeping them all in memory. But the real power here is that there's an abstraction behind the scenes called Micrometer. And Micrometer is a distributed tracing, it's a metrics, a time series database abstraction. It's like SLF4J, but for metrics. And it supports a number of different backends: AppOptics, Azure Monitor, Elastic, Ganglia, Google Cloud Stack Driver, Trace, StatsD, and of course VMware's own Wavefront. Now, Micrometer is not new. It's not it doesn't depend on Spring. In fact, it's the other way around. Spring depends on it. And so as a result, a lot of different projects use Micrometer besides the Spring ecosystem, right? And so you'll find integration for emitting metrics, much the same way you'll find integration for logging in all your favorite libraries. I'll have Log4j, and it's easy to take that and turn it into logging in your favorite abstraction, right? Because of that, a lot of people can plug in their particular monitoring system of choice, and they can use that to talk to their backend service. And a very common choice in Kubernetes, for example, is Prometheus. Obviously, I am a big fan of VMware's Wavefront because it's just it supports both trace and metrics. Obviously, Netflix Atlas and Graphite are also very, very strong content. I mean, there's just a lot of good ones, right? Lots of them you could try out. One of the big themes in Spring Framework 6 is that we're integrating, we're going to have a stronger observability story. So there's two sides to that coin. Right now, there's metrics, which is what we're looking at here, and there's distributed tracing, which takes the form of Spring Cloud Sleuth. Spring Cloud Sleuth is an abstraction for tracing the flow, the movement of a message from one node to another in a system, right? So from one hop to another, each hop creates a span, and the whole thing, the aggregate from A to Z is a trace, and so you have multiple spans per trace. Well, that abstraction is also pretty popular, and we integrate with something called Brave, right, which is a kind of an abstraction. So it's already kind of possible to plug in different implementations there, and certainly it's been done. And we also have this Micrometer support, for which it's definitely intended that you can plug in different abstractions. A lot of that work, and again, I don't know what it looks like just yet because it's still ongoing. A lot of that work will get more integrated in Spring Framework 6. I don't know what that looks like. Maybe it just means that you get more metrics for different application context events. Maybe it's just, it's now a core dependency, and so every integration can now emit metrics that make sense for them. I don't know. I don't know what that looks like just yet. We're still working on that story as we speak. But improving observability framework wide, that's a big theme, right? And everything that Spring Framework does in turn, informs what projects that build upon it will do, right? So we'll see what that looks like. I can't give you a lot of details at the moment. I just don't know. Okay, so I've got my application. We kind of hand waved away some of the other features in the Actuator, including the info endpoint, which you can use to identify your service, including all the different endpoints for profiling and heap dumps and all that. But anyway, we've got an application. It's observable. What I want to do is I want to take this application to production. And these days, production means Kubernetes, right? As often as not. It means some sort of container orchestrator. As often as not, that's going to be Kubernetes. And I want this to run as efficiently as possible. And I wanted to get it into production in Kubernetes. So I can use, I can take this application, containerize it very easily using the built-in build pack support, right? And so it's already been configured. You don't have, this is not related to that. I can ignore this. The Spring Boot Maven plugin automatically supports build packs. That's a cloud native computing foundation specification for turning application into a container. And you can actually use build packs for other types of workloads as well. So go to buildpacks.io and you can see there's an easy way to take an application artifact, be it a .jar, .NET exe, a Go application, whatever, to take that code and turn it into a container, right? And that container, you can then Docker tag, Docker push to the container registry of your choice. Obviously, I'd love it if you used VMware Harbor, but whatever you like. Google Container Registry, GitHub Container Registry, all these things work just fine, right? Or Docker Hub, that works fine too, right? Obviously. So you want to send that, you can then use that container in your Kubernetes manifest and deploy it. Now, by default, if we had chose everything on start.spring.io, but if we hadn't chosen the Spring native support, what we would get is a container that contains a JRE and our application, which is fine, except these days, if I can, I want my application to be even more svelte, even more fit for purpose, if possible. And one way to get that is to use GraalVM. Now, GraalVM started its life as an ahead-of-time compiler replacement to replace the spaghetti code, spaghetti C++ code that had mired hotspot for so many of the last several years, several decades even, a couple decades. But it also eventually sprouted a ahead-of-time compiler. So if you know what the just-in-time compiler is, it looks at frequently accessed code paths in your code and replaces it with native code, which is great, right? That native code runs faster. And it's one of the reasons why Java, even though it's an interpreted language, right? We actually, for some reason, we managed to get the worst of both worlds by default, right? Most of the time, when you have a language that's interpreted, like Python or Java or like Python or JavaScript or whatever, what they do is they take your source code and they turn it into bytecode, and then they run the bytecode. And so it's still interpreted. You're interpreting the bytecode, but at least you don't have to compile it, right? With Java, we compile the code into bytecode. We do the work that most of the languages get for free manually, and then we run the interpreted bytecode. And that bytecode is slow. It's not super fast, right? It's only thanks to, it's not slow compared to something with less types and less optimizations, but still, you're not gonna get native speeds by using an interpreted bytecode machine. That said, because of that just-in-time compilation, it's possible to get applications that actually behave more efficiently and are more performant than otherwise well-written C code, for example. Because with C and C++ and the like, you get a lot of resource initialization. Resource acquisition is initialization, right? RAII. And so lots of little bumps of memory. I malloc some memory, or I allocate some memory, and then I do something with it, and then I clear it up all in the same scope, right, as quick as possible, because you don't want that to leak. And so you have these little bursts of memory, and that's very inefficient, right? With Java, it can see the whole world. It can see the whole world of memory, and it can see the memory graph, and it can say, okay, look, I've got a tidy little lump of memory over here that's growing. I'll be sure to clean it up once these 3 things are finished, right? So we can do some very efficient things. That just-in-time compiler is pretty amazing. It sets Java ahead of the pack for a lot of different organizations. In fact, large organizations like Google and Alibaba, whatever, they know about this dynamic. They actually, before they release their services, before they turn them on and make them available for production, they warm them up so as to trigger that just-in-time compilation. So if that just-in-time compilation is so amazing, it stands to reason, wouldn't it be nice if we just proactively just-in-time compiled everything? If we just proactively turned everything into native code? And that's what the AOT compiler is. AOT compilation is what every other language just calls compilation. It's taking your interpreted source code and then turning it into a native image, as opposed to being a still interpreted thing. And so AOT compilation is amazing, right? There are 2 benefits that I see. One is a huge, stark reduction in memory footprint, which is, I think, the biggest deal, right? The other one is faster startup time, which I suppose if you're doing Lambda and functions and the like, that's a big deal. It's just not my use case, so it's very hard for me to get too excited about it. Most of my services I just start them up and they just stay up. So it doesn't really matter if they're, even if I'm scaling up, if it takes a second to scale up versus, 30 milliseconds. Again, my use cases aren't such that that's going to be a big deal, but maybe yours are. And the point is, because of that, because of native, you also get support for that. So GraalVM is awesome, but keep in mind, it is different than your JRE. It is not a full-on JRE. It has to do a lot of things to make your code work. What it does is it looks at your code and it looks at all the code that your code uses, and it says, oh, this type, by virtue of the fact that it's being used from your user space code, is reachable. And that code in turn calls this other method on this other object, and therefore that type is also reachable, right? So you get this reachability graph of all the things that are being used by something in the code base. Everything else, GraalVM throws it away, right? Throws it all away. And that's a bit of a problem, because for all of its stodginess and its warts, Java is actually a very dynamic language. Like I said, it actually has a lot more in common with the likes of Python and Ruby and JavaScript and Lua and whatever than it does C and C++, largely because of that runtime aspect, right? The ability to ask the runtime questions, kind of like we could with Lisp, right? It's very unique, and if you think about it like that. And so that runtime creates problems because that doesn't exist once you compile to native code. And so we have to simulate that. And we also have to take into account some of the dynamic things that would defeat our reachability detection at compile time. So remember, with Java, it's possible to have a Java lang string, multi-line string, of course, where you have the definition of a class in it. You can say class cat, curly bracket, or class dog, curly bracket, curly bracket. You have a string with a definition of a class file in it. You can then compile at runtime that type. You can then create a proxy. If it's an interface, you can create a JDK, a Java Reflect proxy invocation handler and a proxy out of that. You can also serialize it if it implements serializable. You can reflectively instantiate a new instance of it and invoke methods on it, all without ever having a concrete reference to a dog or a cat. It's just Java lang object and strings everywhere, right? And so that reflection is all that evades the deterministic sort of reachability graph detection that happens at compile time. So we need to provide it information to say, hey, look, I know you don't see this, but we're going to use these types at runtime. They're not here. They're not used yet, but we're going to create a proxy at runtime. We're going to do this reflection at runtime on this type, and you don't know which type it is, but please don't throw that type away because we need it later, right? So you need to provide configuration. That configuration can be done in terms of JSON configuration or command line switches. But point is, it adds up because Java is a huge ecosystem. We're closer to 30 years of Java than we are not. And so as a result, there's just a large swath of stuff out there for which GraalVM isn't immediately the best fit. And what we want is to make GraalVM a really good fit for the entire Java, entire Spring ecosystem, right? And remember, Spring is now, depending on how you look at it, it's nearly 20 years old. So it's got a pretty substantial ecosystem in of itself, second to nothing, right? There's nothing out there that has a larger ecosystem in the Java community, save for Java itself, right? The Java ecosystem can be said to be larger. And because of that, this is a pretty ambitious goal. It's easy to take stuff developed today, but what we want to make happen is you can take stuff that was written in yesteryear, upgrade it to the latest and greatest versions of Spring, and then see that code compiled to GraalVM native image code. And that'll be natively supported. We'll have native support for native in Spring Framework 6.0. So for now, a lot of that work that we've done to make it native work out of the box is part of a separate project, a research project, experimental project called Spring Native. And I've got that in the class path here. And you can use this today. It works just fine. In fact, a lot of that work is being merged into Spring Framework 6. And if, who knows, if this conference was just a month later, maybe I'd have something I could show you there in Spring Framework itself, but it hasn't quite yet released parity, reached parity, but it's getting there, right? We already have a working prototype. We obviously have a working thing that does the job, as we'll see here. So Maven P, that's the native profile. I'm going to skip test because if I don't, it'll run the tests in the native context, which means it'll compile the tests, which means I'll have to wait not 1 minute, but 2 minutes, right? Go away. Got it. So what this is going to do is it's running my application. It's going to compile it. It's running this Maven plugin. Sorry, not the Maven, but it's running the AOT plugin. And the AOT plugin is going to look at the source code and provide any optimization. So remember earlier, I said we have to provide configuration, and we also have to do whatever we can to reduce the need for the configuration, right? I just mentioned that reflection is one of those use cases that requires configuration. Well, wouldn't it be great if we could remove substantial swaths of that configuration of that reflection at runtime, at compile time, and then therefore negate or moot the need for all that configuration when we do compilation? So the AOT plugin has a hand in both transforming your code in such a way as to avoid reflection and avoid a lot of these things for which you need a configuration, and then to generate the configuration for the things that still require it. So if I go here, I can see that the AOT plugin has given me these proxy configs and reflect configs and all that stuff. So Spring Native knows about all the common paradigms of Spring and Spring Boot. So it generates the configuration for you. It also does transformations on your code. So if I go here, like here's, let's see here, static Spring. If I look at the spring.factories text file that's in the meta-inf directory of various jars class path, I see a service loader mechanism. Well, that's been turned into Java code, right? We're no longer loading a resource from a jar because that would be inefficient. And plus we'd have to provide the configuration for all that. So this gets turned into a Java class that is in turn the aggregate of all the spring.factories service loaders on the class path at compile time. We get that. And then we also get, where's my code here? Generated runtime sources, source main Java. We also get all the Java configuration, all the add configuration, all the add bean methods, all that stuff gets turned into functional configuration. So here we're programmatically registering beans for you. So my REST controller, before it was detected at runtime when I use it on the JRE, but now it's being programmatically registered with the application context here, and that transformation happens unbeknownst to me. I just write the code the way I always do, and it gets turned into this behind the scenes, and then that gets fed into the GraalVM compiler. The result is something like this. Here's my application, target, customers. It's going to take a second the first time because it's going to ask me to allow the network request. I hit Control-C. Okay, there we go. So 68 seconds, 68 milliseconds, right? 68 1,000th of a second to start up an embedded web server, an embedded database, and so on, while I'm also screencasting. Not bad. And even more impressively, so pgrep customers, that's the PID, right? So PID equals this. And then Josh env bin RSS by PID, right? So that's taking 107 megs of RAM. That includes everything I need to run the application. It includes the application itself. You can then use Alpine Linux, like an Alpine Docker image, to run this on in a Docker container. Now, obviously, I'm running on a Mac, so I don't want a Mac native binary to go into my Docker container. So the nice thing about using the Spring build pack support out of the box is that it creates a Linux image, a Linux native binary in a Linux container for you. So it runs the compilation of your source code in the Docker image itself, and then it packages the resulting binary in the container for you. So you can do Maven Spring Boot build image, and it'll give you a Docker image with a Linux binary. That said, there's also a GraalVM GitHub action. I don't know if any of you are using GitHub actions. They're pretty neat. One of the benefits is that you can do cross compilation. You can do matrix build. So you can say for all these different operating systems, for all these different versions of Java and all these different versions of whatever, do one of each, right? And so you can actually have the same GitHub action, same GitHub action pipeline run for Mac, Linux, Windows, etc. Okay, so this is a pretty trivial example. You'll see that this stuff will be integrated into Spring Framework 6 and Spring Boot 3. So what does that mean? Well, it means that this core stuff, like the stuff you've just seen that doesn't really affect you, I don't know what'll happen, but I would be surprised if we still have an extra Maven plugin, for example. Obviously, all the repositories for the releases, but not yet GA, not yet on Maven Central stuff, that goes away. I think you'll probably still have the native profile with GraalVM, Maven plugin, but I think a lot of that other stuff that we have here, including the extra dependencies, Spring Native and all that stuff, I think that just goes away. I don't know, like it'll be kind of interesting to see, but there's some obvious opportunities. We haven't even really been optimizing yet. What we're just trying to do is to make it work, and it does work splendidly, and huge swaths of the Spring ecosystem now already work on Spring Native. So there'll be a bit of a hiccup right after Spring Framework 6 where we're moving everything to the new thing. And I can't promise you that what you learned today using Spring Native will translate exactly to what you're going to need for Spring Framework 6, obviously. But conceptually, at least, I think there's a good chance of a lot of that being the same, just because packages and refactoring and getting the code polished and all that are a thing. Okay, so there's our service, our application's up and running. It's containerizable. It's got low memory footprint. Let's see, localhost, customers. There you go. So now I want to build another service, and here what I'm going to do is I'm going to build an edge service. Okay, so we want this service to use the reactive web support. We want it to use Java 17. We're going to use Spring Boot 2.7 M3 because that gives us the new GraphQL support, right? Spring Boot 2.7 is not Spring Framework 6 and Spring Boot 3. It's Spring Boot 2.7, obviously. So it's going to be releasing soon. I think next month. When is the next? It's like every 6 months we release a new Spring Boot version. So it's got to be coming up here pretty soon. So Spring Boot 2.7 will include Spring GraphQL support. And let's see, we want the reactive web support. I guess that's it, right? So, okay, let's hit generate. UAO edge.zip. Come on. Did they do a new release? They probably did. Good for them. Okay. Okay, so I've got this edge service, and this edge service is just going to be a client to my downstream customer service, yeah. And so that naturally, there's what I want to do is I want to make this data downstream available to the consumer, right? And I need to, I want to be able to make that data available to the consumer. It's an HTTP service, so we'll say @bean web client. Whoops. I'll use the reactive non-blocking HTTP client. This is a good idea, even if you're not building reactive HTTP services themselves. This is a great way to consume other HTTP endpoints, okay? And then I'll build a CRM client, and I'll have a thing here where I can inject the web client, okay? And I'll return a reactive stream of customers, yeah? So I'll say record customer integer ID string name. Alrighty, and return this .web client .get .uri HTTP localhost 8080/customers. And I want to get that and turn it all into a reactive stream. So again, it doesn't matter that I'm talking to HTTP here because it's just a reactive stream at the end of the day. Okay, component. And I can use RSocket as well. RSocket is a very nice exchange to Flux. No, retrieve body to Flux. Thank you. It's reactive. RSocket is a very nice binary protocol that comes from Facebook that makes it easier to do service interactions, message exchange and so on. You can do request response, you can do fire and forget, you can do bidirectional streaming, you can do channels, you can do all sorts of interesting message exchange patterns with RSocket. It's more efficient, it's not porous, it's not like a HTTP 1.x where you have all text. It's just a very nice protocol. But again, because I'm just using reactive streams, I'm using these reactive types from Project Reactor, which build on the reactive streams, you just get fluxes of stuff. You get fluxes and monos of your domain types, right? Okay, and because of that, I get these built-in operators. I can say, oh, I want to do on error resume, when there's an exception, I can say, do that, or I can do timeouts. I can say duration, dot of seconds 1. And I can do retry. There you go. Retry, when retry, dot, back off, 10, duration of seconds. Voila. Okay. So these operators, these three methods here, these aren't particular to my web client. They're particular to Flux, which is pervasive. It's in all things reactive in the Spring ecosystem, right? And so whether you're doing RSocket or HTTP or GraphQL or whatever, you can use these operators to make your code just that more robust. Okay. So here's my client. Now I wrote this client myself, right? I had to write this client myself the old-fashioned way by typing it out with my fingers, which is great. I don't like having to do that extra kind of work. And so a lot of us will reach for different clients, declarative clients, and I love those, right? To our chagrin, they've become exceedingly popular, and we didn't really anticipate that. And when we started supporting OpenFeign, which is a project that came out of Netflix and that got open sourced and became a separate project called OpenFeign, and then we created Spring Cloud OpenFeign, which integrates that with the Spring stack. When we created that work and made Feign work with Spring's request mapping and all that stuff, we had no idea just how prolific and popular that would become, and that in turn, begat other inquiries. So people were wondering, well, how can I do reactive declarative clients? And Feign never really quite got there, did it? So, and we weren't in control of that project. So our answer was always, well, maybe consider Spring Cloud Square, which is a project that's in the incubator, but that uses Square's retrofit project. And retrofit supports asynchronous and therefore potentially reactive style declarative interfaces. Now, it was not signature compatible with Feign because they're not the same project, but they served a lot of the same kind of goals. You give it an interface and you decorate those interfaces with annotations, and then you can then you get a proxy of that interface that you can then invoke, and that'll in turn result in HTTP calls being made for you on your behalf based on the annotations there. So you don't have to actually describe how to serialize it, what endpoint to call, what URL, all that stuff. You can just do so declaratively. And that in turn inspired questions about using RSocket, right? And so I created something called Spring RetroSocket, which is an incubator project, right? So Spring-projects-experimental /Spring-RetroSocket. And RetroSocket it's a declarative client, interface-based client for RSocket, yeah? And that works fine too, but these are all not the same thing, obviously. And so Spring Framework 6, one of the things we're working on is having a core abstraction, core in Spring Framework itself, and to ship those declarative clients in a consistent way. So rather than having these three different pluggable, like I built Spring RetroSocket from nothing, right? Whereas Spring Cloud Feign obviously used Feign, which is a bigger project, and Spring Cloud Square obviously used Square's retrofit support. So we plugged in and adapted those, whereas with Spring RetroSocket, I just built from whole cloth. And suffice it to say, I'm sure I didn't cover all the use cases in RetroSocket as Spring Cloud Square and Spring Cloud OpenFeign have covered. So to have a consistent engine, an abstraction in the core of the framework, and then to ship out of the box support for HTTP for reactive and not reactive, HTTP and RSocket support, that's going to be a big deal. That's also coming in Spring Framework 6. Okay, so here's my basic client. I want to consume that data. Now, let's create a new controller here. Okay, just we're going to say CRM GraphQL controller. Yeah. And what I want to do is I want to create a GraphQL endpoint. GraphQL is another protocol that was created by engineers at Facebook back in 2012 who were confronted with a bit of a tension. They had their clients, and their clients wanted all the data in one fell swoop and one page load, and they wanted to be able to read and manipulate all that data as quickly as possible. But Facebook, for its part, had different services, and those things didn't always have the same, they weren't microservices per se, but they were different network requests, and so there's a tension there. Clients want their stuff all in one screen as quickly as possible. They don't want to have to do lots of service orchestration and composition. On the other hand, it doesn't logically make sense to couple these things. They shouldn't, all this data shouldn't be redundantly specified for every single API request. And so you get into this pattern. If you've ever built microservices, you know what I'm talking about. You get into this pattern of, okay, I've got these 5 different microservices, but the client wants a worldview that makes it look like they're one cohesive API, right? And that's what they are. They are. It's just that they live on different services. And so you get this edge service pattern, which I love. I use it all the time as a proxy, as a go-between between the client and the downstream service. And there you handle things like composing all the data to create a new view of the data, a new model for the client to work with, and hopefully more efficient, right? Instead of making the client create 3 different network threads in a bandwidth constrained Android device going through a tunnel on 3G, instead of making the client do that, you do the service orchestration on the server side when you're on fiber in the same data center, in the same data center, able to do all the work as quickly as possible. And then you send back the view that the client wants. And the client will get the view tailored to its use cases. The problem, of course, is what happens next year when they need a new view? Well, now you've got to revive the work on that edge service to add that, or somebody's got to do the work there, right? And it might be that the folks gifted at building iOS apps aren't particularly gifted at updating the server-side implementation in Spring and whatever. So that becomes problematic, right? So what they want is to make it easy for clients to get the view of the data they want without the backend team having to constantly retread the same ground. So they created GraphQL. And so GraphQL works by letting you, first of all, provide schema. So we're going to create a new folder here called GraphQL. And we're going to create a new file here called schema.graphqls. And you describe the types in your application. And the root type in all GraphQL objects is a type called query, off of which you have fields. Those fields you can invoke, you can pass parameters. But here, I want to get all of the customers. Okay. Well, this type customer, I haven't defined it yet, so I'll do that here. And this field, by the way, it's a field named customers. The type is an array of customer. If I just said that, then it'd just be a single customer, but it's an array. So I want to have 0 to n customers. Each customer has an ID, which is just anything can be an ID, but it has to be meaningfully distinct for you, semantically distinct for you. Okay, so this is my query. There are other kinds of special, well-known root types. This is the most common. Most of your APIs most of your fields will live under the query type, right? And you can see this is a very common thing. It's very useful to be able to explore an API's queries. So here's all the different queries for that. There's a spacefaring company here, SpaceX. You might have heard about it. They might be big one day. Who knows? So they have this these endpoints, and you can interact with them. You can explore them. Yeah. So here I've got my types. I've defined this type. It maps to my Java type here, and now I want to create a controller that supports that endpoint. So I'll say schema mapping. Type name is equal to query, and the field is going to be called customers, right? So it lines up with what we just put in the schema there. All right. And of course, in order for this to work, I'll need my CRM client. Add that to the constructor. Return this.crmclient.get customers, and voila. Okay, so I'm providing a very simple GraphQL controller there. This schema mapping is saying, hey, this method should be invoked whenever somebody tries to resolve this field of this object. Okay, now this is a bit verbose because remember what I said, queries are a very common thing. So rather than doing that, we can actually use query mapping, right? And with query mapping, you no longer need to specify the type because it's implied. And then the only thing you could specify is the field, but even that can be inferred by the name of the method, as you see here. So this, with this signature, is exactly the same as that, right? It's sort of like how request mapping Git mapping is a specialization of request mapping with a method equal to Git, yeah? Okay, so query mapping is great for reading data, but there's other kinds of things you might want to do. You might want to update data, right? So you can have a mutation. And a mutation is just another type. It's a way to update data. And this is one of the things I love about GraphQL is it's very pragmatic. If you look at, REST, I love REST, but I still don't know if I'm doing it right. It's only been 20 plus years, I have no idea. And this is the thing that's so, inertia sapping, it just takes away, you just end up in the mud, spinning your wheels. Is it right? Is it restful? You don't know. There's just so many ways to have this discussion, and it's worth having because doing a good job is worth doing. But if you're trying to build services and you're not trying to build REST APIs, right? If your focus is on building a service, then maybe there's other ways to get it done. And especially if you're in a homogeneous sort of ecosystem where everything is using GraphQL or whatever, then you might be better off just focusing on one particular thing as opposed to hedging for the flexibility implied by HTTP. So with updates in particular, with HTTP, oh my goodness, do I do a post or a put? Do I do HTTP 200 or 201, or if it's long lived, do I do 202? Like, I don't know. Do I return the location header? No, maybe not. What happens if I do options? I mean, there's just so many. Do I do it? And then let's not even talk about hypermedia, right? Hypermedia gives you a way to define the types of your system to create a very clear understanding of contract and implied implicit contract about what the shape your API takes. But that's all provided for you by the schema here. So I can actually create a mutation that says, update, and it'll take an ID, ID, whatever, and it'll return a customer, something like that. I don't know. You can create your own fields, and that gets turned into a method. So here I would say mutation mapping, customer update, integer ID, and this becomes a argument, a Spring GraphQL argument, right? So that maps very naturally to what you're trying to do. And in the same way, if you wanted to do a query that had parameters, you could say at argument here, integer ID, whatever. So you can actually do customers. You could create a new query called customers by ID, and then put that argument in there as well. Okay, so let's revert this so that it works the way we expect it to. Go back to the types. Don't need that. Okay, let's run it and see what that gives us. Oh, you know what? We can't see what it gives us without our handy dandy console. So I'm going to bring in graphical, right? Graphical, get it? And I'll specify a port here equals 9090, and I'll restart. Or not. Did I forget to hit the button? Come on. Is it compiling? Okay, it's up and running. Fantastic. Okay, GraphQL. 9090. Voila. Okay, so there's this query customers. And notice that I'm getting control space. It says, okay, you want customers, eh? Okay, you want the ID field? Great, here's that. If you want the name field? Great, here's that, right? It automatically adds the data that you asked for, but no more. And this is great because if you want to do, let's say I wanted to have a new type here for my schema for the customer. Maybe the customer has a profile, right? Profile. So that's a new type. Okay, so type profile ID. And then in here, record profile integer ID, right? This might be a separate microservice call, but I can easily just create a schema mapping endpoint here. I can say type equals customer and, profile for this root customer. So when somebody asks, when the GraphQL client asks for the customer profile, this method gets involved to resolve it. So actually that's doing, I'm doing another network call, but the client doesn't know that these are two network calls. It just knows that it's asked for the ID, the name, and soon the profile, right? If I actually implemented that endpoint, and that would just work. And it would, for each one of those customers, it would call back and get the profile for them as well. All right, my friends. Well, I think we looked at just a few of the things that are in store for Spring Framework 6 and Spring Boot 3. We looked at the very beginnings of the native support. There's a lot more here. There's actually a component model that looks kind of like the Bean Factory post processor, but at compile time. So it's the Bean native configuration something processor. And that'll change. Those SPIs will change in Spring Framework 6, I imagine. But basically the same idea. You have a like for Bean Factory, and for individual beans, you got Bean Factory post processor and Bean post processor. We'll have analogs to that in the Spring native world and the GraalVM world for compilation time post processing. We have looked at the incredibly good support for, it's fast already. Spring Boot is very fast these days. As you can see, I'm running everything here. It takes less than a second. In some cases, like this last one, what does this GraphQL application take? 0.7 seconds, right? So this is on the JRE. I'm not even doing anything yet. We looked at the smart support for Kubernetes briefly. We looked at smart support for containerization. We looked at GraalVM. We looked at reactive programming. We looked at building GraphQL endpoints, and we looked at some patterns for building more robust services. Hopefully, you got something out of it. Hopefully you got a feel for what's coming. I also talked about the new baselines, the new Java baseline in Jakarta EE. There is one last thing that is a cripplingly bad breaking change that I feel like I should mention. And I'm not trying to sneak it under the rug or anything. It just makes me very sad and it hurts to talk about it. They're removing the support for automatically turning an image into a banner. So you can't just put banner.jpg in your source main resources folder and have it get turned into ASCII art. Don't ask me why mistakes were made. I have no idea. I'm sure it'll be okay, but anyway, happy to answer questions. Thanks for your time, everybody. Hope you have a great day. Stay safe out there. I wish we could all do this in person, but it's one of those years.